In this part, we will see how we can design the base connection using IdeaStatica program. So we will take the reactions from the previous video and show how to go through the program and choose the different parameters. So let's recall, these are the reactions that we extracted from the SAP 2000 model. We have a normal force, or a vertical reaction, and a horizontal reaction, and we are considering a pin connection. So this is IdeaStatica program. When you access the program, choose connections. You will see this window. So choose the one showing you a base connection, and then under the geometry, choose the first one, and then under design, choose shear connection. And after this, leave the parameters as it is, and then create project. When you create a project, this is what you will see in front of you. So you have different tabs: project, design, check, report, materials. In design, this is the part where you can change and play with the different parameters. So as you can see, you have the connection in front of you. And in this part, you have connection 1. It is divided into members, load effects, and operations. So we will start by the members. So press column. When you press column, you will be able to change the column section. When you press column, the side window changes. You can see here I have the cross section. So press edit according to this arrow. You will see the different shapes for I-beams. You can also change the material. So if you have A36 or different type of steel, and if you press these 3 dots, you will see the different sections that you can choose from. So as you can see here, I will choose W, and then I will choose the section which conforms to the designs that I made in the previous task. Make sure but just that here the notation of the section is in millimeter. So if, for example, you have W12, it might be W150 or 200. It depends, and we have the notation between the milli and using the inch in the given sheets. Leave the other parameters as it is, but go to model. You will see here the model type. So choose NVYVZ. This refers to the type of forces that you are choosing that will be acting on the connection, and you will design it based upon. So after finishing the part under column, let's go for load effects. So you will choose LE1, and when you choose it, you will see this table on the side. So here you can insert the different values that you have. We have here minus 1200. This is a default of the program. We will change it to consider the values that we have. We have a horizontal reaction and a vertical reaction. So these are the 2 values that we need to introduce into our connection design. So now you can see I inserted the 2 values under N and VZ considering the directions, and when you insert a value, you will see an arrow showing you the values that you have introduced. Why are we introducing the N as considering a negative value? Because this is a force from the column compressing on the foundation. So we have the action and the reactions. What the SAP shows is the reaction, and now we are designing considering the action. Let's move to the operations, and as you can see, the window also on the right will change. You can choose here the parameters related to the base plate, the anchors, and the wells. So the first thing that I will do, I will leave the part under the base plate as it is. If you want to change the thickness of the base plate, you can do this. And here for the offset, this is a special case. We will not consider in our course, and then we can move to the anchors. So also leave the anchors as it is, but you can change these 2 values, which is minus 90 and minus 80, considering the distance between the anchor poles. So here you can see I changed these 2 values to minus 100, and when I did this change, you can see that the figure also changed. So these are the spacings between the anchors that we have. If you look at the wells, I have wells around the flanges and around the webs. So I choose first the flanges, and I choose that I will have weld, fillet weld from both sides. You can see here the E70. If you press it, you can also choose different types of electrodes. And then you have the weld size, so you can choose any value. You can start by, let's say, 8, and then check whether you need to increase it or not. You do this for the flange and also for the web. After you do this, move to check and then move to the report. And when you move to the report, choose the detailed report and then generate. So the program will generate for you the check on the design parameters that you choose in the previous steps. Now let's look at the report. So the report first shows the design parameters that you considered in the previous steps and shows you whether these are safe or not. For example, I can see that the anchors are not okay, and they are not okay in shear. So I have here a value that is larger than what is allowed. So this is something that I need to go back and change. With the report to see what is exactly wrong and what parameters I need to change. So here I am looking also at the anchors. I can see their distribution, and I can see that the 4 anchors are unsafe. So I need to change the 4 anchors design. By changing their design, I could change the grade, I could increase the diameter, so you have different parameters to play with. Here I'm looking at the weld, so you can see that the weld is okay, nothing I need to do to change for the weld. And for the weld, you can insert the number of the size, or you can leave it to the program to choose it. So based on this, it will give you a value of the minimum size required in your connection. So now when I went through the report, I can see that the problem is with the anchor design. So based on this conclusion, I decided to go back to the design tab and then choose the anchors. And here for the same grade, I am choosing a larger diameter, and then I press OK, and then I repeat. So I will repeat the same step to generate the report and see whether it is okay or not. You need to do this repetition till you make sure that there are no warning signs in your report. Usually the warning signs will be in a red writing, so you can see exactly that you have a problem with this.